Hi, everybody. I'm Holden, and I'm here to talk a bit about our experience at Turbo Button from bringing Adventure Time to Gear VR. Start here with a little video to give you guys some context about the game.
Tiny? Tiny! Blink twice if you can hear me!
Let us not be friends.
Oh, what do you see in these two, huh? Always faffing about like children.
Finn, I know you like somersaulting and all, but I'm getting a little dizzy back here.
So that's what the game looks like. It's a third-person platformer. Again, you can grab it now, and it's free on the store. So over the weekend, I was getting a lot of questions about the game, and the most common one was, how did this happen? So last year, my friend Nick and I were working at a studio called Magic Pixel Games, and we met Ryan Harwell, who worked in digital development at Cartoon Network at their GDC party. We set up a meeting after GDC to pitch some mobile game concepts that we were working on at the time. Magic Pixel was mostly doing free-to-play mobile games at that point. And during those pitches, we found out that Ryan was really excited about VR. We had also been doing some VR stuff in game jams as hobbyists on the side, so we just started chatting and geeking out about VR instead of talking about our mobile games. And when we eventually decided to do VR full-time with our little team at Magic Pixel, we got back in touch with Ryan to see if he'd be interested in doing something. He'd been sharing his DK1 around the office, and a lot more people over at Cartoon Network were starting to get into it, so he told us to come up with some pitches. We spent about a week, and we made this prototype for a third-person platformer. It featured Capsulefin and Cube Jake. And being used to game jams and rapid prototyping, we were able to get a lot of the game sketched out pretty quickly. So we had, at this point, all of Jake's special abilities. We had basic camera movement, some UI, a little bit of an idea of how we would communicate some of the movements as well, and the basic gameplay figured out. We had very, very quickly figured out that a lot of things that we were hoping to do would not work, trying to adapt a platformer into VR. But we also learned about things that we should try and spend more time on. So we also had another stroke of luck, and that was that Nick and I released A Night at the Oculus a couple days before our pitch in Atlanta, and it went viral. So a few people in the room during our pitch had already seen the game around the internet, and that pretty much gave us the credibility that we needed to be able to land a big VR project like this. So those little side projects that a lot of people are doing, like, they really do pay off. A few months later, Cartoon Network decided that they were ready to move forward with the game. But in nearly the same time, we found out that Magic Pixel was getting acquired by another studio, and that they would no longer be doing VR games. So at this point, we thought the project was dead. However, the founders of Magic Pixel knew that we really wanted to make this game, and amazingly, they offered to let us see it through. They gave us their blessing to continue talking with Cartoon Network on our own, and said that if we wanted to pursue it, that they would allow us to take all of our prototypes with us. So when we told Cartoon Network what was going on, they didn't even blink, and they said they wanted us to move forward with it. And at the end of last year, Nick and I left Magic Pixel and started Turbo Button. So Turbo Button and possibly this game would not exist without the generosity of Magic Pixel and the trust and vision of Cartoon Network. So I am extraordinarily thankful to both of these companies, and I'm not just saying that because they're in the front row. So when we were first starting out the game, we were aiming to make a 15 to 30-minute experience, initially as a showpiece for conferences and expos. We had three main goals. We were trying to fill it up with fan service, make it comfortable for everybody to play, and do some experimentation with storytelling. It wasn't a very long game, but it had a lot of moving parts, and we had a very tight development schedule, and we were also a new company. So our core team consisted of 2 hybrid designer engineers and an animator. And then we got some help on the outside with other areas of art, like our environment art and our character models. We did build the game in Unity 4.6.7 as well. So we started off by figuring out how we could focus on the fan service and storytelling parts. We decided that as fans, that we didn't want to be Finn and Jake so much as we wanted to hang out with Finn and Jake. There were a lot of games that allowed you to play as one of the characters, but the feeling of hanging out with them was something that we just wanted to try to explore a bit. So at the beginning of our game, you befriend Finn and Jake at a picnic, and you're interrupted by Magic Man, who, for those who aren't familiar with Adventure Time, is basically just a big jerk. Magic Man curses you and turns you into a giant balloon. Finn and Jake promise to track down Magic Man and to turn you back to normal, and they tie a string to you so that you don't float away from them. In doing this, we're scaling the camera in real time so that it feels like you're getting bigger as this process is going on when you're getting cursed. And we're also then explaining the size difference between you and the characters. You control Finn with the gamepad, and you get dragged behind Finn because you're tied to him. We also thought that this would help give you a reason to feel like affectionate towards the characters and allow them to have some cool interactions with you. But one, which for a lot of players it does. But one unintended side effect was that players also quit complaining that they couldn't see their hands in VR when we introduced this concept. By setting up the fiction around who they were, and part of the fiction was that they did not have hands, that actually helped a lot with players just accepting and jumping right into to the story. We had certainly a lot of inspiration from other games. Lucky's Tale showed us how powerful the simple interactions of a character looking up and waving at you could feel. And we were certainly thankful for them helping us get started with a lot of our very basic design. But beyond that, I think that Tearaway from the Vita was probably our biggest inspiration on the gameplay side. We tried to create a lot of memorable little moments that break the fourth wall in a meaningful way. So we made it a priority to embrace these opportunities, not only because they used VR really well, but because they allowed us to leverage the talent of the show's cast in a pretty cool way. So this is one of my favorite moments from the game where Jake is taking a selfie with you. So once we had figured out this story, we started designing our levels around that to build out this narrative. Part of the fiction is that you're chasing down Magic Man with Finn and Jake, and as such, our levels are very linear. From the design side, we have very little lateral movement. The player usually moves straight through Z-space or vertically through the environments. And we did this because we found it to be the most comfortable kind of movement with a third-person camera. We have very little to no backtracking, which means that you're mostly looking forward if you're actually moving because you're looking towards Finn and where Finn is going. Throughout the levels, we did try to make opportunities for players to stop and look around, and we found that audio was one of the most powerful ways for us to do this. So these little jack-in-the-boxes that you're seeing up there on the left are collectibles that you can smash. They yell at you and taunt at you from afar, so you'll hear one in the distance and start looking around for it. And we also have a bunch of little ambient creatures that can whiz by your head like this bee. One thing that we got a lot better at as we went on was designing specifically for performance on Gear VR. So even though we were trying to make these very linear levels, the initial designs didn't really lend themselves too well towards occlusion culling. So this is what the forest level initially looked like on the Note 4. And this is what we ended up shipping with. We kept the same basic forward movement, but we are forcing the player to move a little bit around the path. I can show what this looks like from above. So even though we are now forcing a little bit of lateral movement, we're still keeping a small amount of forward movement, which certainly makes it more comfortable than if it was just a sharp turn. The game's camera system was in constant development up until about a month or so before release. And we spent a lot of time tweaking it and testing it with people outside of the team. What we eventually shipped with worked well for us, but it does have limitations that make it not a catch-all solution for any game. So by no means would I want to suggest that this is the one way to do a camera. I'm just going to try to help you guys understand what we ended up doing. So the camera's movement is dynamic based on Finn's position and velocity. There are no rails or splines giving the system a path in any way. So it is just two floats for a target z distance and a target height that get adjusted by trigger volumes at different points in the levels. The camera moves towards those target positions whenever it's possible. So the problem with doing it this way, which was somewhat quick to implement, is that it was very easy for the camera to clip through geometry or end up in uncomfortable places, depending on where the player would move Finn around. So what we eventually came up with for that was this system that is based on casting rays in all directions from 2 points. So we're casting rays from the camera's position and that target position that we're calculating behind Finn. The rays are spread out across multiple frames to save a little bit on performance, and we can also adjust the density of rays on the fly with our camera volumes as well. We cast from these two positions to handle situations, specifically like moving around corners or backing up against geometry. So in this image, the red rays show invalid directions that the camera should not move in, while the green rays show directions that would have enough room for it to go. And the corrected target position is at the intersection of those rays. So here I'll show the same little scene in motion. You can see the yellow sticky note icon. That's representing our corrected position. It's going to jump around a lot because the parts where it's actually OK for the camera to fit are going to move based on where the camera is moving and where Finn is moving. But by adding this third point to interpolate between, the camera's actual movement is somewhat smooth and doesn't end up colliding with any geometry. The characters were probably the most important thing for us to get right for the fans, and we partnered with Super Genius Studios to create our models. We're spending about 2,000 to 3,000 tries per character, or up to 6,000 tries in stereo, and the characters make up most of our vert budget in the game. All of the lighting is baked into their textures, and we only use unlit shaders at runtime throughout the game. Finn and Jake are separate skinned meshes, and this allowed us to animate them independently of each other, which was really important for Jake's special abilities. We had a separate model for each one of Jake's abilities. Here with the parachute, you can see that the backpack version of Jake just hides down into the backpack as the parachute pops out. But we also had some more complicated Jake abilities. One of his defining characteristics from the show is his ability to stretch around into really crazy shapes. And this was a big challenge for us to figure out. For a long time, we thought we were going to have to rely on canned animations, then that we'd be leaning on IK, and it just started becoming a mess. We were very limited with what we could do, and it all just felt very canned. But then during the development of Adventure Time, we took a break for the VR Jam with SMS Racing. And we used a tool off the asset store called Megashapes to build some of our track layouts. We kind of realized that this tool was very good at building really squiggly shapes in Unity. And we kind of put 2 and 2 together, and that ended up becoming Jake's stretchy body. So the stretchy body is a procedural tube mesh that has 4 control points. And they get updated every frame while Jake is moving around. The tube is blended into a skinned mesh version of Jake at the other end, so that it can be fully animated. And we're able to then just move a control point for where Jake's head should be around based on where the player is looking and also where the player's position is, the camera position. We also were able to just get away with shading this as a solid color all the way through, and that just happened to work with our art style, so we got lucky there. We used that same tech to create the bendy motion with Jake's grapple ability, except this time we're also moving Finn along the spline so that he gets pulled behind him. The game's environments are inspired by scenery from the show, but they don't take place in specific locations, and this was a pretty tough call for us to make. As much as we would have loved to build out iconic set pieces like the Candy Kingdom or Ice King's layer, we ended up having a lot more flexibility with our poly count and with our visuals if we didn't have to capture really specific details that players would be looking for. So the result is that we think our game looks like it's from Adventure Time, but it doesn't capture those specific locations. So we started every level off with a very simple white box version. At this stage, it would be playable from start to finish, including all of the platforming puzzles and the enemy encounters. And there were very, very few changes between the white box versions and the final versions of each level. We worked with an off-site environment artist, and we would send her the white box levels as we would have them finished. And she'd replace them with art assets as she made them. So she would just do that all directly in the Unity editor with us. We gave her some restrictions, like keeping the verts low and reusing textures whenever possible with her art. But we weren't really worrying about performance on Gear VR just yet. At the iteration stage, it made a lot of sense for us to force ourselves to adhere to certain restrictions, but know that we were going to have to tighten it up for performance later down the road. So what that part entailed was that after a level was mostly finished and we were happy with the assets, we would set them all up in a test scene to atlas them. So this is the test scene for the forest level. So we used a program called Meshbaker that you can get off the asset store that just works right within Unity. And we would re-UV all of our assets using this program, basically making a copy of the originals. And each environment then was able to share material. So for the huge majority of development, each level actually fit on a single 4096 texture. We eventually expanded this into 2 4096 textures per level after we did some more optimizations and were able to afford it. And this is an example of what that gives us. So in this scene from the mountains, we're at a total of 6 draw calls in mono here. The whole environment happens in 2 draw calls, which is 1 static batch and 1 dynamic batch. And then the rest of everything is light maps. So this freed us up to do a lot more with the characters and our game code because we weren't spending that much on the environment rendering. So this method did have a lot of limitations as well. We can't tile or scroll UVs, so everything has to fit between 0 and 1 on the UV maps. And this created some more work for our environment artists to use this workflow. But it really was also just a one-time process, because after we were happy with the assets and we were getting ready to bake them, we could just set up all of the UVs to fit within that area on, for the versions that we were going to use in the game. Anything that had a scrolling texture, like the waterfalls and the rivers, we did end up using a separate draw call for. We also aggressively optimized our environment assets at that baking stage to remove our back faces whenever possible. So like with the docks on the right, you can see that you can't actually see any geometry from under them, even though there are actually places in the level where you can get under them. So we would have 4 or 5 variants of each of our assets with different back faces manually cut out, depending on which part of the level it was used in. Our skybox consists of the camera clearing to a solid color, and then we have a bunch of sprites rotating around it. The total radius of that, I think, is about 25 meters out from the camera. And then we have a shader on the sprites to force them to draw behind everything else. This had a cost for alpha, but it was a lot cheaper than us doing a high-resolution skybox on the GPU. And it also allowed us to independently animate each layer. Like we have a layer of clouds and a layer of wisps, and then another layer of high clouds there. I can quickly go through some other stuff that we did that was very specific to Gear VR. So we're toggling some things on or off depending on which device we're running on. So this is what the game looks like on Note 4. And this is on S6. So it may be hard to see in the screenshot up there, but the S6 version actually has a significantly higher texture resolution. And then we added some environment props that you can see here. We designed the game around the Note 4. Actually did not get an S6 until very late in the development process. So all of the features for S6 were added at the very end. But in many ways, this actually made it a lot easier for us to toggle these features on and off, because we didn't have to compromise the Note 4 version, and everything was just very contained. Our limits for draw calls ended up being quite a bit lower than the recommended limits. We are rarely going over 40 draw calls in stereo on the Note 4, and those are at moments when we have lots of characters and VFX on screen. Our vert limits are also quite a bit lower. We're usually around 55,000 verts on the Note 4. You can see like some of the places where we saved on Geo, specifically with the walls, by increasing our texture resolution. Everything except our skin meshes were either static batched or under 300 tries so that they could batch dynamically. So all of the ambient creatures, even though they would animate, we would have we would just do transform animation on them. So their wings would each be a separate mesh from their bodies and that kind of thing. This also included stuff like the mushrooms and each part of the Jack-in-the-Box. So those lower limits let us do way more with our game code. And you can even see in this screenshot as well, we're actually able to get away with a lot of alpha on Gear VR. Here we have the God rays coming down. We have a steam effect coming off of the waterfalls. We have sparkles happening in the waterfalls. And we also have sparkles happening coming up from the bottom of the level there, along sometimes with snow effects going on. And this all runs on the Note 4 because our draw calls everywhere else are so much lower. So I will say that these slides are going to be online along with this presentation later on, in case you're trying to keep up with that. We had a few snags in development, mostly with things that were either undocumented or somewhat hidden with Unity. And I should make it clear that I love Unity, and I would probably have few employable skills with game development without it. But these are some of the problems that we had to work around. I also want to give a shout out to Chris Pruitt, who helped us figure out some of these problems down the stretch. For most of the game's development, we were GPU limited. We were running at half resolution on the Note 4 and really stretching our light map budget. But when we learned that the Note 4's GPU should be able to handle way more than we were throwing at it, we started looking a little bit more closely and eventually figured out that we were GPU limited because all of our textures were ignoring their compression settings. So the Oculus developer guide recommends using ETC2 compression. But ETC2 is only supported by Unity if you're forcing OpenGLES 3. Even if the phone supports the ETC2 format, Unity will not allow it to use it in OpenGLES 2 mode. So we were not able to use OpenGLES 3 in this game because of some other bugs that were in the versions that we shipped with. So we ended up staying on GLES 2 and switching our texture compression down to ETC1. So here's what the game looked like with the ETC2 textures. And on Note 4, we were not hitting frame rate. And this was probably about a month and a half or so before our ship date, so we were pretty concerned at this point. We thought we were doing everything right. We're only at like 30-something draw calls. Why are we having this problem? And everything was just running uncompressed. So here's the game that we shipped with ETC1 textures. We're locked at 60, and we literally quintupled the texture resolution as well on the Note 4. We actually were also able in this version to add some more environment props and increase our draw distance in both of the levels from anywhere from 20 to 30%. So ETC1 worked fine for our art style, but it may not work for everyone. You definitely do get more banding on some of the gradients, and you don't get the biggest loss is alpha. We still ended up using true color uncompressed textures for our light maps. And that's just something that we ended up having to take a hit for because it definitely looks way better with uncompressed light maps. So here's another issue that stumped us for quite a while. The Unity profiler was showing us that our vert counts on Android were way higher than they were in PC builds. And at that point, we redesigned our first level to improve its occlusion culling, as I showed earlier. And the vert counts went even higher on Android after that. So we somewhat realized at that point that occlusion culling wasn't working properly. We went on to learn that occlusion culling is simply ignored in Gear VR builds currently in Unity 4. So it's completely ignored in Unity 4, even as of the latest patch. But it comes with a massive CPU overhead in Unity 5 to a point where it makes it mostly unusable. Oculus and Unity are both actively working on this, and hopefully there will be a fix very soon. It didn't come in time for us, so we had to come up with some other solutions. So this is one that we tried based on a suggestion from Chris. We pulled in the far clip on our cameras to about 5 meters multiplied by our camera scale. And we added in a third camera that starts at about 5 meters and goes to our normal far clip. That third camera renders to a quad positioned about 5 meters in front of the player. And we make that quad visible to the other cameras. So the result is that everything after 5 meters out from the camera is only ever rendered once instead of once per eye. And the other cameras are just seeing that on a render texture on the quad out in front of it. This works because the stereoscopic effect somewhat breaks down a few meters in front of your eyes. You can't perceive depth beyond a certain distance, and again, that's going to depend on your camera scale. And although this looks really awesome in a little video like that, it's not something that actually ended up working for us. On the plus side, it was quick to implement, and it gave us a lower overall vert count, but it ended up causing us to have some even worse GPU issues because we were adding another render texture. And we actually also increased our draw calls because we had optimized down so far in the first place that it was essentially just causing us to render everything 3 times. So we opted not to go with this method, but I have read that a similar technique is used by Fireproof Games and Omega Agent, and it seems to have worked very well for them. So this is worth a shot if you're having these kind of issues. So what we ended up doing is nothing fancy, really. It doesn't look nearly as cool as that other slide, but we're turning off all of our renderers at the very start of the scene. We had to tag every asset in the level, not at the prefab level, but actually in the scene. And we're setting up trigger groups that turn the renderers on as you walk through them. So this is kind of what that looks like. It's not real occlusion culling, but it's close enough. So we're kind of faking out a level of detail system here so that we're not taking any CPU costs for occlusion culling whatsoever. And this saves us about 2 or 3 seconds on milliseconds rather on the CPU time, which was a pretty big deal for us. Finally, this is another problem that seems obvious in retrospect, but it stumped us for a while. And it's also not VR specific. So we were getting massive slowdown when looking in certain directions. And for example, like looking straight forward here, the game would run at about 10 frames per second. And if we looked at a little bit to the left or a little bit to the right, it would be fine at 60. And this particular view is all static meshes. There's nothing really fancy going on, nothing moving. But then if we moved a little bit further back here and we take a look at maybe what's behind it, we have this thing. And this guy had an animator on it that was set to based on renderers. And it happened to be moving a static collider without a rigid body. So all of the collision was getting regenerated every frame as a result. And that's a common Unity problem that people run into all the time. But this is particularly difficult to debug when occlusion culling doesn't work, because you don't realize that something is animating and causing it at the time. So just be wary that this occlusion culling issue, at least until it's fixed, can manifest in some other ways. Really quick, I want to give some props to some of the asset store packages that we've made part of our regular workflow at Turbo Button, not just for this game, but for some others as well. We very liberally embraced the asset store for help, and it was an awesome resource for us. I think that our game turned out way better with some of these assets than it would have if we had tried to do all of this tech on our own. We've also packaged up some of our tools and some of our code examples for some of the stuff that we showed today, and they're available on our GitHub page. We're going to be posting up some more stuff later on next week that we couldn't quite get ready before Connect, so you can take a look at it sometime next week. I want to thank the Turbo Button team, Nick, Ralph, and Melissa, who came up with a lot of this stuff. And I want to thank Cartoon Network for not only being an awesome partner, but for encouraging and letting us be open to share all of this stuff with you today. So I'm going to hang around a bit after this talk, along with the team, to answer any questions that you guys might have if you want to ask something now. But it's also pretty easy to catch us online. If you haven't played the game yet, again, you can check it out in the Gear VR Cafe. We'd love to know what you think of it. Thank you, and enjoy the rest of Connect.